In the last section on graphing inequalities, we had more than one line on the same graph. At times, depending on the problem, there were times that the lines crossed. This module deals with finding the exact spot that two lines cross each other, which will be useful information when doing other applied problems. Since we will be dealing with lines, we will be going back to working with equations rather than inequalities. Here's an example of two different equations that, when graphed, cross at a particular point. Notice that the first equation, y equals negative 4x plus 5, is written in slope-intercept form, while the second equation, x plus 2y equals negative 4, is written in standard form. By graphing both of them, I find that the lines cross at the point 2, negative 3, right here. This means that the point 2, negative 3 is a solution for both of the equations, and we call it the intersection point. Graphing is certainly one way that you can use to find where two different lines cross. However, that method could take a long time, and if the lines don't cross at integer points, could be difficult to pinpoint. For those reasons, there are two other methods that can be used to find the intersection point, both of them by using algebra. In this video, I will talk about the first method, known as the substitution method. To illustrate this method, let's work through the same two equations that we graphed just a moment ago. Y equals negative 4x plus 5 and x plus 2y equals negative 4. In the substitution method, we do what it sounds like. We will substitute the value of one variable for the same variable in the other equation. Notice that in the above two equations, the first equation is solved for y. I have y is the same thing as negative 4x plus 5. Since negative 4x plus 5 is equal to y, we can substitute that negative 4x plus 5 in for the y in that second equation, and we will create a third equation. So instead of writing the second equation, x plus 2y equals negative 4, instead I am going to write it as x plus 2, and in place of the y, I am going to put negative 4x plus 5 equals negative 4. It's exactly the same equation as that second equation, but in place of the y, I put negative 4x plus 5. Notice that this equation only has one variable in it, and then we can solve it like we have solved equations before. So I'm going to go through and solve this. I'll do it fairly quickly, getting the x all by itself on one side. The very first thing I'm going to do is I am going to get rid of the parentheses. So I have x plus negative 8x plus 10 is equal to negative 4. So then combining my x's, negative 7x plus 10 is equal to negative 4. Subtracting 10 from both sides, I would have negative 7x is equal to negative 14, which means then dividing both sides by negative 7, I would have x is equal to 2. Now, once I know that x is equal to 2, I still need to know what y is. So now I can go back into either one of the original two equations to figure out what y is. The easiest equation to use would be y equals negative 4x plus 5, because I know that now x is equal to 2. So I'm going to put 2 back in there and solve this for y. So I have y is equal to negative 4 times 2 plus 5, or y is equal to negative 8 plus 5, which means y has to be equal to negative 3. So I have 2, negative 3 as a solution. And I want you to notice that the point 2, negative 3 was the same solution when we went through and we graphed the lines at the beginning of the video. This substitution method of solving equations is really a lot easier, a lot faster than going through and doing all that graphing. Here's another example of the substitution method. I have two different equations. The first one, 2x plus y is equal to 4. The second equation, y equals x plus 1. Notice that the second equation, y equals x plus 1, is solved for one of the variables. It's solved for y. So I am going to go through and I'm going to substitute x plus 1 in for the y in this first equation, and I am going to create my third equation. Instead of 2x plus y equals 4, I'm going to say 2x plus x plus 1 is equal to 4, since x plus 1 and y are equal to each other. Then I am just going to go through and solve this particular equation. So I have 3x plus 1 is equal to 4. Subtracting 1 from both sides, I get 3x is equal to 3, and that must mean that x is equal to 1. Once I know that x is equal to 1, I can go back really into either of these two equations to figure out what y is, but it makes the most amount of sense to do the one that is y equals x plus 1. So if I put the 1 back in for the x, I'm going to have y is equal to 1 plus 1, so y is equal to 2. So if I graphed these two different lines, that would mean that they would intersect at the point 1, 2, and that is the intersection point for those two different equations. You may have noticed in the examples I've done so far that one of the equations was always solved for y. However, it certainly also works if one of the equations is solved for x, as in this example. Notice that in the second equation I have x is equal to 6 plus 2y. So I'm going to come back to this equation and I'm going to put 6 plus 2y in for the x and create my third equation. So now my third equation is 6 plus 2y plus 2y is equal to 10. And I'm just going to go through and solve that fairly quickly again. So I have 6 plus 4y is equal to 10. Subtracting 6 from both sides, I get 4y is equal to 4. And now y is equal to 1. If I know y is equal to 1, I'm going to come back, and once again I come back to either one of the two equations, but it makes sense to come back to the equation that's solved for x, and I am going to put this 1 in for this y. So I have x is equal to 6 plus 2 times 1, so x is equal to 6 plus 2, or x is equal to 8. So the intersection point for these two lines, if I were to go through and graph them, would be 8, 1. Here's another example of a problem to solve. I'd like you to stop this video, solve the problem yourself on your own piece of paper, and then you can turn this video back on and watch me go through and solve this. Okay, hopefully you've had time to go through and solve this. If I were going to do the substitution method for this, I would certainly take a look at this very first equation that I have. I know that x is the same thing as 2y plus 1. So I'm going to put 2y plus 1 in for x in that second equation. And now the third equation I have is 3 times, in parentheses, 2y plus 1. Plus 2y is equal to negative 5. And now I'm going to go through and I'm going to solve that. So I get 6y plus 3 plus 2y is equal to negative 5. So I get 8y plus 3 is equal to negative 5. Subtracting 3 from both sides, I get 8y is equal to negative 8, which must mean that y is equal to negative 1. Once I know that y is equal to negative 1, I'm going to go back into one of the two equations, and I will choose the equation that's solved for x. X equals 2y plus 1. I'm going to put negative 1 in for that particular y to figure out what my x is. So I have 2 times negative 1 plus 1, which means that x is equal to negative 2 plus 1, or x is equal to a negative 1. So the solution set, the intersection point for this particular set of equations is negative 1, negative 1. Although the substitution method always works, There is another method that I will talk about in the next video that, depending on the equations, may work even better. After watching all the videos in this module, you will be able to find lots of practice problems in the module to help you perfect your skill with the substitution method.